I don't think humans before would have showered. I tried it and I said, you know what? Let's see if it works, because my skin at that time was terrible. Oily skin, oily hair. And even to this day, 4 years in, I have not showered. Around the third month, it stopped getting oily. The smell was almost completely gone. In fact, I will interview college students to see if they can guess the last time I've taken a shower. The reason I also stopped brushing my teeth was humans never had malocclusion and they never had tooth decay and any of that before the agricultural revolution almost. And then I also heard a little bit about carnivore from some people. So then I said, let's see if this links up with carnivore. So I said, you know what? I'm going to be a living test subject. The second I start doing carnivore, I will stop brushing my teeth. And to this day, I've had no problems. Have you not noticed? I haven't brushed my teeth an entire year. And she panicked. I went to the dentist, and even the dentist looks at my teeth, and then he says, it looks like you brush your teeth once or twice a day. I looked at that and I went, I knew I was doing something right, because even the dentist himself couldn't tell the last time I brushed my teeth.
Ladies and gentlemen, boys and girls, and super intelligent shades of the colour yellow, you're welcome here, of course, however you identify. Today, my very special guest is Blaise, who has a story of intrigue, love, hate, war, peace, and incredibly long lunchtimes or something. I don't know. Blaise, tell us about it.
My story, oddly enough, starts with carnivore. And yes, carnivore was a good start, but there was something I did a little bit before carnivore, which was very, very strange. It was the fact that I heard some guy from Australia randomly said, you know what? I'm not going to shower. And he didn't shower for 5 years. And I saw him on this one TV thing and I went, what the heck? So I was like, you know what? I might as well try it, right? I don't think humans anyways before would have showered, or they might have done something similar every now and then, but it wasn't an everyday thing, I would assume. I tried it and I said, you know what? Let's see if it works, because my skin at that time was terrible. Oily skin, oily hair, like all that stuff was just through the roof, really bad. And I said, okay, you know what? We're just going to go with it. So I went for it. And even to this day, 4 years in, I have not showered. And about 2 months of that entire process, my skin was really, really oily. But around the third month or so, it stopped getting oily. And I was like, why? Why is this happening? This is really weird. And not only that, the smell was almost completely gone. In fact, I eventually will make a video where I will interview college students to see if they can guess the last time I've taken a shower. I don't think they can, but regardless, I will eventually do something like that, because why not? That was a really, really interesting experience. What do you think why do you think that's working? Or what do you think the smell is, or any of this stuff? Like, what's your thoughts on this?
Yeah. Okay. If I had to guess, I would say several things. First of all, I believe it was Queen Elizabeth who is reported to have had a bath twice a year, whether she needed it or not. Apparently. So it's only actually a very recent thing that people have thought it hygienic to shower on a daily basis, or bathe, or, whatever it is, and to use scented soaps and to scrub the dermis away and, do all of that kind of stuff. And because it removed some of the mankiness, shall we say, that is thought to have been quite rampant back then with people who never brushed their teeth ever. The average person wouldn't bathe or shower because there wasn't such a thing to be had, like, ever. The royalty, as we were saying, talking about, bathing twice a year, whether they needed it or not. Goodness gracious. That's, over the top. So the precedent is there that this is a recent thing that humans have been doing, washing themselves on a daily basis. I'm always telling people not to change their diet overnight from anything to anything else, to always do a transition between two states of dietary norm, precisely because microbiota get very upset when you change the resources on them suddenly. And given that there's a large microbiota that lives with us in, around, and on our skin, if they are always having to re-establish themselves every single day, then maybe they're at a constant initial warring factions phase that can lead to bad smells and all sorts of other, because they'll exude chemicals to try and kill each other. basically, these bacteria. That may well also be associated with poor skin in some way as well, because it's never given enough time to establish itself and come to an equilibrium, which takes some time. And maybe that's what you're talking about with at least your perception, that you aren't offensive in any way, in a smelliness way or whatever. I'd like to hear others' take on it, so I think you should do that thing. I mean, I take your word for it. I mean, are people running away from you at 100 miles an hour every time you enter a room, or what's going on?
Well, oddly enough, I go to college, and actually I'm basically finishing my college year. I'm planning, or somewhere along the lines, thinking of becoming a doctor or biochemistry along those lines, because I'm really, really into biochemistry.
Oh, I bet for that and not doctor. Depending on the outcomes you're looking for. We can talk about that later. Go on.
So in terms of what happens whenever I walk into the room, nobody notices. In fact, I don't know if this is proper to say at all, but I have had intimate relationships, I guess you could say, and there was no frustration. In fact, there was only pleasure. So something along those lines. It seems as if the smell is not bothering, or maybe it's even attractive. Who knows? I think of it sort of as a pheromones, possibly with the dog sniffing another dog's ass. I have no idea. I have no idea in terms of that. I also think it does have something to do with the microbiome, because I also did the same thing with my teeth. And well, I guess we'll get into that eventually, where I just stopped brushing my teeth and suddenly my teeth are perfectly fine. I even went to the dentist, and the dentist couldn't tell that I didn't brush my teeth. We'll do that story a bit later. But yeah, that's been my experience in terms of the not showering thing. Okay. I did notice one very interesting thing. When I lift my armpit, the armpit is actually, the smell is much more noticeable, but it's only if the armpit is open. If the armpit is closed, no smell. Armpit open, smell on. So
keep your arms down. keep your arms down. Well, I think you can imagine already what the thumbnail of this video is going to look like.
Yeah, I think.
Okay. Well, maybe you've hit on something. Who knows? Obviously, I wouldn't dismiss it out of hand. I'm also probably not going to stop showering, bathing, or whatever, personally, because I think that there would be ructions around here if I did. It's something that you've made work. Fine. Okay. Interesting. All right. What else have you got for us?
Yeah. Well, not just have I stopped showering, I decided, you know what? We're going to also, this was actually on my carnivore journey. The second my carnivore journey started, the reason I also stopped brushing my teeth was because I heard guy by the names of Dr. Mike Mew, also talk with some other person. She was some woman dentist, can't remember what her name was. And they were basically saying, yeah, humans never had malocclusion and they never had tooth decay and any of that before the agriculture revolution almost, or it was just very rare. Yeah. And I said, wow, that's strange. And then I also heard a little bit about carnivore from some people. So then I said, that's even more strange. Let's see if this links up with carnivore. So I said, you know what? I'm going to be a living test subject, and I'm going to put myself to the test and see whether or not this is or isn't true. So I just said, okay, you know what? We're just going to go straight at it. The second I start doing carnivore, I will stop brushing my teeth. And to this day, I've had no problems. In fact, a year in, my mom at that time, she saw me walk into the bathroom and then she said, "Oh, Blaise, are you about to brush your teeth?" And I said, "Have you not noticed? I haven't brushed my teeth in an entire year." And she panicked. She freaked out and she said, "What? That's ridiculous." Immediately after that, she said, "Okay, you know what? We're going to the dentist." So I went to the dentist, and even the dentist looks at my teeth and then he says, "Man, it looks like you brush your teeth like once or twice a day." And I looked at that and I went, I knew I was doing something right, because even the dentist himself couldn't tell the last time I brushed my teeth. There was no plaque on them at all. He was amazed. In fact, he actually didn't even believe that I was eating only meat or doing all this stuff, because he was like, there's no way that this is possible. I don't believe it.
Apparently, he's wrong.
Yeah, exactly. So, I mean, I was amazed by the results, and I have a couple ideas for this one, a little bit more so for my skin than my skin microbiome, because I have heard before that the skin microbiome could play a role in terms of cytokine production, if I remember correctly. I wasn't entirely sure. I read a paper on that really, really long time ago. So I thought, okay, maybe be something with the mouth microbiome. And after that, I also saw you and somebody by the name of Sarah Pugh talk about deuterium. And I sort of thought about that and I went, that's interesting, because if I'm eating carbohydrates, I'm basically giving, well, one, there's a couple of reasons. It's a growth factor, but I guess the deuterium part of it could be a growth factor for the bacteria. So in this case, it could be promoting more of a certain bacteria than another kind. And this is what leads to the tooth decay or anything like that. I'm not entirely sure, but that was my thought on it anyways, because if I introduce carbohydrates back in, or if I try, which I don't want to ever do, but if I do, I'll have a really bad reaction. But if I do, I'm pretty sure I'm going to have the exact same problems that I had before, because I had so many dental problems. I had like 5 cavities before, even though every single day I would brush my teeth and I was told, brush your teeth with toothpaste. It's really important to keep your teeth protected. And it didn't do anything. I still had problems. What's your thoughts on that as well, in terms of the biochemistry as well?
Look, both perfectly valid hypotheses that you could test experimentally at some point in some way, perhaps. I think that sounds fine. On a more basic level, the way I would normally probably go about explaining a phenomenon of that, because I've got the same thing, clean teeth, no furry stuff. Nothing grows. I haven't had a cavity in years. In fact, I've got at least one cavity in a rear molar that's actually healing now.
Whoa.
Yes. They can heal. They do heal. And the dentist telling you that that's impossible. Of course, they're going to tell you it's impossible, aren't they? It's not impossible. Your teeth are a living tissue and they can heal.
Wow.
Anyway, we'll get to that later. So, dental health better than it's ever been. Anytime I do let any carbohydrate slip in, straight away, the fur is back. Now, that is the way that those particular bacteria that enjoy that service of the carbohydrate, nom nom nom, they grow in these furry colonies that attach to the dental calculus, and they eat the sugar and exude, I should say, acid, basically, and pour acid all over your teeth enamel, and that's the cause of the problem that we have with our teeth being eroded away.
That would make a lot of sense.
So basically, you change your diet in such a way as to remove that fuel provision, and those bacteria that like to do that cannot prevail, and they basically go into stasis and or die off, no problem.
I mean, that would make a lot of sense. I'm so curious, how is your tooth, like the cavity, healing? Because to me, obviously I probably thought the same thing than the dentist. It's like, he told me you can't heal the cavity, right? Or it's impossible to heal the cavity. Yeah. And then your cavity's healing.
That's right. I've actually healed several. This is not the first one that's occurred. A combination of a diet which does not allow those acid forming bacteria to prevail, to live, to be there in any great numbers, that solves the problem from one direction, i.e. the cause of it. And then the solution to it is in encouraging your body to service you with enough adult stem cells that the cavity in the tooth becomes a priority and there's enough resource for that. Then the stem cells will migrate through the vascular part of the tooth, situate themselves where the cavity is, differentiate into a tooth matrix type cell, basically, which then calcifies over time.
Yeah.
Simple as that. When you think about it, people don't run around saying, broken arm, we're going to have to shoot you. There's no way that we can solve that problem. Well, bones will knit and re-heal. All you need to do is set them in the right place so that they can do it. No problem. Well, why would you imagine that a tooth can't heal? It's basically just a calcified bony structure with a matrix the same way that bone is. It has a vasculature too, by the way, and a cavity up the middle with the nerve and everything.
I gotta ask, would cerule help with this in that sense? Because it would allow for the... Yeah. How does that work exactly in terms of the stem? That one.
Yeah, right. That's Stem Enhance Ultra. That's the flagship product of the fine folks at Cerule. The only company with whom I have any joint venture whatsoever, and the only product I promote whatsoever anywhere on the interwebs, by the way. So that should tell you something. This product is involved in causing your bone marrow to release more of your own adult stem cells than you otherwise would, so that you become flush with adult stem cells, basically. And what that does is it causes your body to grab those adult stem cells and bind them up to any cells that are worn, tired, dysfunctional, diseased for any reason, that kind of stuff, and replace them with new ones, pretty much. It's fantastic. Awesome. You can't ever run out of adult stem cells. There's no way for that to occur. All you're doing is you're basically pumping it. Every time you take 2 of those capsules, you get a 25% increase in circulating adult stem cells at peak. I think about 2 hours later from memory. Don't quote me on that, though. Something like that.
So about 2 hours after that?
Yeah, because they peak up after you ingest the capsules. And then after that, they'll start to decline as the body basically grabs those cells, takes them up and uses them to replace old cells that need renewal, basically. Fantastic. Okay. Incredible. Powerful product.
By the way, because I was originally going to go into chemical engineering or be a chemist myself, the purification process of this, it removes, I'm assuming that because it has to separate, or I would hope so anyway, it separates most of the phytotoxin content from the actual product that you're looking for, right?
Yes.
Okay.
Absolutely. There's a video or a series of videos, I can't remember which, on my Fine channel where that is outlined. We speak to the president in charge of the harvest who runs us through the process, and we walked through the factory and had a look at it all going on. So that's all in video format. They're on my channel already for people to go and have a look at.
Wow. Yeah. Okay. Well, I guess I'm going to have a look at that.
I think I can't remember exactly, but it's got how are they raw products, how are they made in the title or something like that, probably.
Yeah, I'm definitely really interested in that because I'm actually, that brings us to our third one. So bone remodeling. I've been doing something very strange as of recently because I'm willing to experiment on myself.
Other than not showering and not brushing your teeth? And yeah, go on.
I'll just go straight at it. Yeah.
I'm all about tact, me. I've always been all about tact. In fact, the only person I know that has less tact than me is this chap. Who, well, he was here. Where's he gone? Ted, you were not seen at the camouflage training. But you just go and twiddle some knobs. Good lad. Right, where were we before I so rudely interrupted? Well, before Ted had his 2 cents worth.
He was so good at camouflaging, obviously.
Yes.
You couldn't tell where he was.
Exactly. It was incredible, isn't it? His training has really come on. We were talking about, you said something about being strange in some way, and I did, fuck me.
Oh,
really?
yeah, another way. That's right. Oops. Well, why not another way to be strange? So I decided to experiment on myself in terms of bone remodeling.
Oh,
and I heard about something called Wolf's Law. I heard about that and I got really interested. And I said, apparently if astronauts go into space, they have problems in terms of their bone density and it starts decreasing because there isn't pressure on them. And that's because of gravity. So I said, you know what? We're going to put that to the opposite test. And I decided, why not try and sleep on the floor to make my bone density even stronger? Because assuming that we're putting pressure on our bones while we're sleeping, I kind of got curious and I said, And I looked on YouTube. Has anybody done this before? Apparently people have done this before. And they said, you know what? It works really well. So I was like, you know what? I'll go at it. Like, why not? There's somebody else out there who's done it. So I'll probably just add myself in. We'll see if it works or if it doesn't. If it doesn't work, I'll just give myself a couple bad nights of sleep. And about the first 3 days, very uncomfortable, I will admit. Definitely not used to it. But as time went on, it's kind of weird because I've managed to get a kind of padding on my left hip. And that's because I sleep on the left side all the time whenever I'm on the floor. Very, very strange. Rib cage as well. I was sort of curious how this would affect the rib cage because I don't know if you've ever laid on the floor, but it's pretty uncomfortable for the most part at first, especially if you're on your rib cage, it's even more uncomfortable. And now it's not actually that uncomfortable, which is very strange. And I was kind of curious if maybe it's just a placebo thing or something along those lines. So I had a massage before and after, and I said, okay, you know what? I'm going to have this massage person basically just trample me as much as they can pretty much on my ribcage area. And we'll see how long I can take it. I go, all right, let's see how well I can last. And at first I didn't last at all. And afterwards I was like, you know what? What's going on? Like, it didn't happen. I didn't have that problem anymore of lasting. I got really is this really working in this case? Because I've heard other versions of bone remodeling occur. I don't know if you've heard of mewing before, but I've seen some mewing examples before and after in terms of the face quite literally changing, but it took them 3 years or something. So I was like, okay, there has to be something. If it's working for the face, then it might work for the bones as well. And I also and this is actually what I will be doing in the future. There will be a video on this. I'm adding cerule to this process and seeing if I could speed this process up even more. There's a lot of experiment stuff I'm testing and seeing if that works.
Cool.
What are your thoughts on that? I'm sort of curious.
Right. That sounds like a standard garden variety version of your body will adapt to the environment in which you place it. Give it long enough to adapt and it will adapt fully to whatever you're doing pretty much. Wolf's Law is one example of those, and Wolf's Law basically states that the robustitude, mineral content, and the actual physical structures that support the bone are all proportional to the loading on that bone, all else being equal. Obviously, endocrine influences, hormonal influences, they're all confounds, absolutely, but I'm saying all else equal, you load a bone and it gets bigger, stronger, more mineral dense, harder, if you like. When you see the breadth across the shoulders of your average Mr. Olympia bloke, the biochromial distance, you can actually measure it. That bloke's whole skeleton over years of training has changed shape from what it was genetically predetermined to be. Because once again, bone is living tissue that is remodelable. Mineral can be removed from it or added to it, as can protein that makes up the basic structure and shape of the thing. And that's what Wolff's Law talks about. However, what you're talking about will also involve the soft tissues around those bony structures, the intercostal tissues between the ribs, for example, the layer of padding that will have been deposited around the hip, specifically the left hip if you're leaning on the left side when you sleep, which you should, by the way. That is the correct side to
I
sleep
knew
on.
it.
The reason for that is because your stomach contents, if you are lying on your left side, the stomach is lower than either in or out from the stomach. So
that would explain
your
everything.
Contents remain without. You sleep on your right-hand side and it all drains back down your throat, etc. Or possibly can if you don't have good sphincter action. It's always good to have good sphincter action, I'm told. Ideal.
On both ends.
Well, exactly, yes. In an ideal world, you want to have control at both ends. Yes. That's what that sounds like. It sounds like your body's adapting to what you're doing. All right, Weirdo, what else have you got? What else are you doing?
Well, I was sort of curious so I was going to talk a little bit about biochemistry, and I was hoping to hear a little bit more. Maybe you could add more detail, or maybe even you could correct me for that matter. I was talking about glucose oxidation in comparison to beta oxidation and comparing the amount of reactive oxygen species generated between them, the Rubisco enzyme as well. I don't know if you've heard about the Rubisco enzyme in plants. Okay, so the Rubisco enzyme in plants, really, really interesting. I actually learned this from my biochemistry teacher in like 2023, I think. Basically, what it does is the problem, well, it's not a problem. It's sort of a benefit at the same time for the plant. The plant will basically generate tons of this reactive oxygen species because this Rubisco enzyme is so inefficient. But at the same time, I could actually see there might be a benefit to this. And it's the fact that in turn, in producing so much reactive oxygen species, the plant is forced to produce so much more antioxidants. And those antioxidants are usually, from what I'm aware of, in the form of vitamin E. And vitamin E, it prevents lipid radicals from being formed, which is very important because as a plant specifically, they have tons of polyunsaturated fat. And a polyunsaturated fat has a double bond, and that double bond allows for the delocalization of electrons. And if it's a radical attacking it, it's going to be even more attracted. So the plant is forced to produce tons of this vitamin E and tons of basically these antioxidants in order to prevent, quite literally, the plant from killing itself. So it's protecting itself from killing itself. And at the same time, producing all of these antioxidants in such high amounts also, I think, from what I'm aware of, would actually help ward against predators as well, because they would be in such high concentrations. So I thought about that and I was like, wow, that's really cool. So is that maybe why the Rubisco enzyme is so inefficient? Because I would assume, because they've already genetically engineered the Rubisco enzyme to be not inefficient, from what I'm aware of anyways, based on the study. They did this in tobacco plants. And in tobacco plants, the tobacco was just growing like really, really quickly in comparison to the unmodified version, which it grew really slowly. So that sort of made me wonder, it's like, is this a benefit or something? So well, yeah, what are your thoughts on that? Because I was like, wow, that's pretty cool.
Yeah. Pretty much the efficiency of all the enzymes in your body will all be collectively adjusted by millions and millions and billions of years of evolution in such a way as to best conduce the outcome, which is homeostasis in some way. Your hypothesis, again, sounds perfectly viable and is something that could be tested experimentally to get a full picture of the outcomes and ramifications. Because while the tobacco plant will grow very quickly, say, maybe its lifespan is thereby decreased. Which might be fine for a plant, but people are probably looking for longevity more than they're looking for some particular antioxidant status, I think.
Yeah, I'm sort of curious. So that actually got me thinking in terms of humans, for that matter. So I sort of looked at that after I learned about that. I found that really interesting. And then I eventually, my biochemistry teacher didn't cover this, so I had to learn it on my own. I wanted to know, what was this sort of, was there a similar sort of thing with humans in terms of reactive oxygen species being produced? How are they produced more often, for instance? Like, what's the main contributor to all of them? What are some of the problems that they come with? Are there any benefits to them in some instances? And what I ended up coming to, there's a lot of stuff. So So for instance, in terms of glucose oxidation in comparison to beta oxidation, glucose oxidation produces about 10 NADH to 2 FADH2, and beta oxidation, it's like around 31 to 15. So the ratio is about 5 in terms of NADH to FADH2 for that of glucose, and 2 for that of...
So I'll hold you there and say, okay.
Am I wrong?
No, I'm not. You're not wrong at all. What I'm going to ask you at this point, though, is for more information. And the information I'm going to ask you for is, Okay.
Well, this is where, in terms of the ratio, ratio could actually make a difference in terms of complex 1 being more prone to electron leakage, which we already know complex 1, specifically complex 1 and complex 3 are more prone to electron leakage.
Okay, so I'll stop you there again. Now you might be drifting off somewhere crazy, because the next thing I'd ask you is this. How many acetyl units do you get off a fatty acid molecule?
3?
No.
Well,
maybe if you had a fatty acid molecule that had 3 in the first place. It depends on the length of the fatty acid molecule.
Yeah, it depends on the length of the fatty acids, from what I would assume.
How many acetyl units do you get from glucose?
I don't remember.
Wouldn't that be fairly vital information? Because
I guess that would.
If the content in terms of acetyl units between a glucose molecule and a fat molecule are not the same, then talking about the ratio of how much NADH and whatever else you get out of each one is completely fucking irrelevant, isn't it?
Okay.
Cool.
Yes.
Run with that.
I'm trying to figure out why glucose oxidation produces more. So that's the only thing that I can think of in terms of why glucose oxidation. So for instance, it was the Randall cycle paper.
Yes.
The old head for a new hat.
Yes.
I think it was, that one.
That article, by the way, was absolute trash. Written very poorly by some people. Yes, it was trash, written very poorly by some people who didn't understand the thing very well at all.
What about the glucose oxidation in comparison to the beta oxidation? I saw at the very end, or around that time, there was a picture with higher mitochondrial oxygen respiration for beta oxidation and not as much reactive oxygen species was being produced out of complex 1 specifically in comparison to that of glucose oxidation. So I would assume that this is because of the NADH to FADH2 ratio. I would assume.
Yes, but that has nothing to do with the source molecules per se in terms of how much is in them, because they are not the same equivalent energy content as we discussed just now. What you're talking about there is actually controlled by the influence of a confounding factor that occurs when beta oxidation is prevalent, and it's the production of FADH2. That's what the control lever is. That's what the confounder is. FADH2 will deliver electrons only at complex 2 and below. It will not reach complex 1. Ergo, what happens then, so-called, here's the theory, is that this vast influx of FADH2 blockades complex 2 and thus leads ubiquinol, otherwise known as coenzyme Q10, to backfeed electrons back to complex 1, which then leak, causing reactive oxygen species concentration to rise, which is correct. That is exactly what happens.
Is there a catch? I feel like there's a catch here.
There absolutely is a catch, because that's presented as a bad thing. Oh, more reactive oxygen species, that's a bad thing. No, the FADH2 is a signal. Here's what it does. It actually carves a part of the Krebs cycle out of the cycle, separates it, and puts a blockade to its use. And it's the section that ends up at the enzyme that transmutes into, when you finally get down to the alpha-ketoglutarate part of the pathway. It's the succinate reaction, I believe it is, that's blockaded that way. That actually cuts those 3 or 4 enzymes completely out of the Krebs cycle. And those are the 3 or 4 that are used primarily by carbohydrates to feed acetyl coenzyme A into the Krebs cycle. So when you have a lot of fat present, ready for oxidation and for use in oxidation, that's what it does. It starts being oxidized. That produces FADH2, which cuts out that other part of the Krebs cycle and renders it basically ineffectual. And then this also leads to the pour back of citrate into the cell cytosol as well, in exchange for oxaloacetate, whatever.
Oxaloacetate, I think it was that one, yeah.
Oxaloacetate, that's the bugger. And then that feeds straight across to alpha-ketoglutarate, thus keeping the Krebs cycle running, all under the influence of this FADH that's being produced in the beta-oxidative process that is not being produced in the glycolytic pathway, basically.
So just to understand this correctly, just to make sure I understand, or maybe I don't understand it correctly because
most people
I'm trying to learn it. Yeah, that's why I'm trying to learn it.
They don't get it either, but okay. Neither do all the Rapetians that do the Rapetian thing and talk about this thing as if they know anything about it. Go on.
Well, it's because I'm trying to, I definitely am trying to understand this. So in terms of what causes aging, I'm assuming that it's inflammation, correct? Or inflammation is a really key part of it.
Aging is multifaceted.
But would inflammation be considered a very big part of that aging process or no?
Yes, it would contribute to the effect that we note when we look at someone and go, they are more aged than another person. It's a contributor.
Assuming that this is the case, would this not also, and also assuming, just to make sure I understand correctly, whether or not this is or not true, does glucose oxidation in comparison to beta oxidation produce more reactive oxygen species per ATP made?
That's impossible to trace, really, until you get a full grasp of the entire metabolic pathway and networks that feeds in and feeds out to everything. It's very, very complex. I'm not sure it's even worth your time, mine, or anybody else's to go through and map all of that out.
Because I've heard about the Serapew thing before with deuterium and it messing up with ATP synthase in terms of basically...
What's your understanding of how that works?
It's related to kinetic isotope theory. Because it's basically what you're doing is you're taking ATP synthase, you're sticking sticking an isotope in there instead of basically the regular hydrogen. And in terms of the regular hydrogen being stuck in there, it's in the intermediate state for a longer period of time. And because it's in the intermediate state for a longer period of time, it has a higher chance of reacting with an O2 to form a superoxide or something along those lines.
That's not impossible, but also that would require a number of assumptions, some of which are made and some of which are just implied, some of which are correct and some of which are demonstrably incorrect.
Enlighten me.
Well, that's a whole lecture all by itself, but basically it boils down to, at the end of the day, this erroneous concept that chemists have that they must account for mass. It's false. Mass is not conserved at the chemical level, at the quantum level. And to suggest that you have to account for everything and you have to have the exact same amount of mass on both sides of every equation is actually not correct.
Okay.
Whoopsie daisy. For example, the thing that they refer to as an H plus in water, number one, is not an H plus, actually. It's actually an H3O plus.
Oh, yeah. Okay. I did know that one. I did know that one at least.
And secondly, it does not literally exist. It does not have a physical presence. It does not need to be accounted for as mass.
If this were the case, then why would I hate bringing these studies in too, or I hate bringing this information because it's not like biochemistry. So why would a place, for instance, India or whatever, right? Let's just account for poverty, assuming that their lifespan is like 67, not accounting for poverty, accounting for getting rid of poverty. It's supposed to be like 73 or 74 at 7 years.
That's impossible. People live however long they live. You cannot adjust that result. That's fabrication. That's not science.
Would you take which other place would you take? Because I don't know a heavy plant eating place. And then you compare that to a place that eats more meat. And then, for instance, why would the place like Hong Kong eats a lot of pork, or Okinawa, or some of these places, they eat tons of this meat, or they eat more of it in comparison to others? And why exactly would they live longer if that was the case? Because I would assume that the two main causes for aging, or at least these metabolic dysfunctions in some way or another, would probably, or maybe even just necrosis of the cell and inflammation, would be inflammation caused by some phytotoxin, or it would be the reactive oxygen species causing a mitochondrial dysfunction, or causing a lipid peroxidation and causing the necrosis of the cell. What would be the cause of aging, do you think, then? Because the only things that I could think of, that I'm aware of anyways, besides vitamin and mineral content, because obviously vitamin and mineral content much higher in meat. I mean, there's a lot of other beneficial things for meat besides that, but why would meat, for instance, make you live longer in that case? Okay,
you are looking for cause and effect relationships. We cannot do science to underpin cause and effect relationships on human lifespans, precisely because we are unable, ethically, morally, or financially, to do such studies. We cannot lock people in labs for their entire lifespan in large numbers of genetically identical and phenotypically identical pairs of individuals, a large number of them, and test things out in this way. It cannot be done. Again, you've given me several hypotheses there around things that contribute to the thing that we refer to as the aging process, and all of them are perfectly valid, I think, including, I would give a list that would look something like errors in DNA replication, occur throughout a lifespan. Changes in those affected by all sorts of things, including UV exposure and whatever else. Glycation of tissues in most people. Oxidation of tissues in many people. Generalized feedback, deterioration in organ function over years, leading to less and less effective function, thus more and more load of problems. And adult stem cells are programmed to be released in smaller and smaller numbers every year as you age, which I think is one of the controlling factors of one's lifespan, personally.
I would probably assume so.
Well, you'd have to. And the other thing is that the rate at which any given bunch of cell lines is dividing living, in other words, what's its metabolic rate, that particular cell line, that also determines things as well, because according to telomere theory, which seems to be pretty robust, it's a bad thing to live more rapidly because the number of cell replications possible gets used up more quickly. So you live faster, die younger, is the theory. Same thing that happens when you withhold food from small rodents. They live longer because their metabolic rate slows down to try and counteract the fact that they need to spend less energy, obviously, because there's no energy coming in. Now, a human body is not similar to a small rodent, really, but some of those concepts will hold. And so that's a good hypothesis. I'd say all of those things are involved in aging, as well as toxic exposures to all sorts of things, both seen and not, shall we say. Also, the stress of dealing with vegan imbeciles, that can age you pretty quickly. Yeah, I don't know.
Oh man, I've been trying to figure something out, because the only things that I can come in terms of like the conclusion that I can come to would be, obviously there has to be some things, because the thing I found weird, or I'm not sure if this study was necessarily so accurately done, but from what I'm aware of, the genomic data of humans was said to be like 120 to 150 years old. And I'm not sure if this was true or not. But when I look at this and I go, this also aligns with a historical reference in terms of the Ethiopian king and the Persian king. So that was sort of like a really big indicator, like what's going on. Because if the Ethiopian king's people were eating meat and boiled meat and this stuff, and in comparison to the Persian king, then I would assume that there would have to be some level of, or some extra level of maybe antioxidants produced, because I would look at it and go, the plant is growing very, very quickly. Well, once again, this is like a not very scientific thing, but it's just a hypothesis. The plant is growing very, very quickly when the Rubisco enzyme is basically fixed. And when the Rubisco enzyme isn't fixed, the plant doesn't grow quickly. And almost similar to that of humans, where when the humans are basically eating, or from what I'm aware of anyways, the humans are eating much more glucose than I'm not aware of the many tall ones, but from what I heard, carnivore has helped people like really skyrocket their growth and really help them quite literally grow taller. I mean, it's anecdotal, I guess, but there's a lot of people who do this thing called looks maxing online. And what they'll do is they'll basically try to look as good as possible. And one of the things that looks good is height. So they would basically try to skyrocket their height, and they would just change their diet, and then their height would immediately become higher, much, much taller. And I'm not entirely too sure, but do you understand where I'm going or no?
Are you talking about adults who have already got fused epiphyseal plates?
No. I'm talking about no. I'm talking about young people.
Right,
Yeah,
that's possible then. Yes.
Yeah. Okay. No. Definitely. Oh God, no.
Not adults, because no
adults.
I'm not going to buy that. Okay. Right. Good.
No, definitely not adults. That's where I sort of got the thought of.
So these are people who are doing a thing online, basically, where they are trying to panel beat their children for somebody else's approval. I'm all for feeding them the right diet and them to maintaining their genetically determined maximum height. Yes, I am for that. I'm just kidding. Yeah. I thought I'd throw that out there.
No, but
let's tell a child from an early age that looks maximization is important. I'm not actually necessarily for or against that either. I'm just throwing it out there as that's interesting. I take no position. Go on.
Yeah. So the thought anyways was the plant is producing such a exorbitant amount of vitamin E to protect itself from lipid peroxidation. This is because they're producing so much vitamin E, prevents lipid radicals. And once again, they have tons of more polyunsaturated fat. So they have to produce these because they are way more prone to this oxidative damage or lipid peroxidation. But us humans, I would assume, are not. However, assuming that we do go through this constant exposure to antioxidants, or maybe constant exposure to reactive oxygen species generation, it would decrease the height of the person because they're exposing themselves to so much of this inflammatory response and reactive oxygen species. That's the thought in terms of the height, and it's the thought in terms of the aging process, at least one of the two really important parts. The inflammation, reactive oxygen species, like you said, telomere length, adult stem cell, basically how much of it is being released. I mean, there's a lot of factors, obviously, and some of them you can't maybe control. Maybe some of them would be genetic, right? And you can't control that genetic factor, but you can still control some of the other factors, or partially anyways. You can control, for instance, at least from what I'm aware of, C rule being able to increase the amount of stem cells. I'm not too sure, but this is still, it's the thought. The reactive oxygen species being generated, I'm not entirely too sure, once again, but I would assume more is generated because of glucose, and that's the difference between the plant and the human, almost the same thing. In terms of the height growth, or at least the growth in terms of the developmental stages, I don't really know if plants have developmental stages. I would assume
many plants absolutely do, yes.
I would assume that they have a level to it. Yeah. So I would assume it's something along those lines. I'm not entirely too sure, but once again, that's
absolutely.
the thought.
It's a rich tapestry, as I've said all along, a rich tapestry, and very, very hard to untease, to pluck out every thread. All we can really do is propose likely contributors. And yeah, I think you've reasonably done so. You've proposed some likely contributors to aging.
So besides glycation, in terms of glucose being in its three forms, I think it was alpha D glucopyranose, beta D glucopyranose, and D glucose. In terms of the D-glucose being the thing that causes glycation and the other two being not, it's all in an equilibrium. Would that really small amount of D-glucose that's unchained really be that big of a contributor, or would more reactive oxygen species be generated during glucose oxidation? Again, it's like, it's the thought.
The theory is that less reactive oxygen species are generated when using glucose, remember? Because it was the FADH2 thing was the switch that caused the outpouring of oxygen species as a consequence of what it takes to cut those other three enzymes out of that Krebs cycle to maintain the fat being used and block the sugar out, i.e. the Randall cycle. Here's the deal. Humans have also developed a huge suite of inherently producible antioxidant enzymes in our bodies.
Yes.
Starting with the master one, H2O2 dismutase. The other thing that human mitochondria have developed in order to relieve that situation is uncoupling proteins, which allow that otherwise unreleasable pressure of the so-called H plus gradient to be released, causing no ATP production at all. That's why it's called an uncoupling protein. And what's released instead is heat entropy. That's what brown adipose tissue does to keep you warm when your body starts getting cold, for example. But non-browned tissue is capable of this under extreme circumstances too, just less so. It's a fascinating thing. Yeah. So that then throws all of those theories into, well, that doesn't make any sense anymore when you understand what's really going on. So in other words, yes, the consequence of switching off those 3 or 4 enzymes at the top of the Krebs cycle, the consequence of that is a buildup of reactive oxygen species, which the human body is quite capable of dealing with using antioxidant enzymes and uncoupling protein. So let's get back to close the circle back to so fucking what?
In terms of the chemist view, there's always a chance, or at least the reaction rate could be increased or decreased based on the amount of these reactive oxygen species being present.
Mm-hmm. So feedback loop.
So I mean, I guess, yeah, in this case, it could be.
Sure, that makes sense.
There's a lot of thoughts that I have anyways for it. And that's just the assumption, because I don't know what else to go off of. Like, I know that, well, I mean, I have a lot of other things or a lot of other possible reasons that can contribute to aging, like in terms of, one, getting less vitamins, essential vitamins and minerals, maybe in terms of meat being way more prevalent, especially in comparison to plants, maybe amino acid content being way more balanced in meat in comparison to plants. I mean, there's so many other factors, but I would assume that one would also play the same role too. But I mean, once again,
all of that I think is for discussion number 2, because it's been fun, but we are actually out of time. So we'll need to close off there. Social media. Tell us all about your social media.
So I am on YouTube. My name is Blaise V. I tried to explain all of the biochemistry stuff, at least from what I'm aware of and from what I know. I do try to explain it to the best of my abilities. Talk about amino acids, phytotoxin content, detox paradox. I talk about a lot of different biochemistry stuff. Instagram, Blaise Vanderploeg. You probably can't spell my name, but if you put Blaise V in, you'll probably end up finding it. I don't really use it that often. Same thing on Twitter, except Blaise V with 3 E's at the end. Yeah.
All right. Super duper. Brilliant. All right,
Yeah.
listen, it's been a pleasure. It's always fun to cross-pollinate. It's always fun to get ideas from others. And it's always fun to throw challenges just to see how people handle them. I think you did well. Frankly, we'll see how well others do soon. Hopefully, some people will agree to debate me on something at any stage soon, but nobody seems to be that keen right now. All right. Anyway, it's been a pleasure. And yep, we'll catch up with you next time around, whenever that is. See you then.
Yeah.
Ciao.